Hello everyone, this is the lecture series of operational research subject and today's lecture number 7 and code for this subject is here ME405. This is the BTech Mechanical Engineering subject. Myself Rahul Kumar, Assistant Professor of Department of Mechanical Engineering, Suresh Gyan University, Jaipur. And today I will discuss about the topic related to special cases in simplex method. This is a topic related to the linear programming problems, and this type of problem involves just like as a man machine type of example and cost reduction type of example means here objective function is always maximize the profit and minimize the cost of this company, right? So this is the main features of simplex method. But in this case, simplex problem is solved very easily, right? For the objective of this topic is here, the student able to understand about it examines the flexible set adjacent vertices in sequence to ensure that at every new vertex. The simplex method uses a systematic strategy to generate and test candidate vertex solution to a linear program, right? And the simplex method is able to evaluate whether no solution actually exists here. No solution will really exist here. And this is a one type of simplex algorithm and construction of simplex tabulation, right? And this is the typical case of simplex method. For the contents of this topic is here simplex method, simplex table, and these are the four cases which is comes under the simplex cases of special simplex method. And first case is here degeneracy problem, alternative optima, unbounded solution, and the infeasible solution. These are the four types of special case in simplex method. And you have already studied about the previous lecture. The most popular method used for the solution is linear programming problem is simplex method. But this lecture with the motivation for simplex method will be discussed first, and and list at one of the vertices of a feasible region. Thus, one way to find the optimal solution is to find all basic feasible solutions of a canonical form and investigate them one by one to get at optimal case, right? In the graphical method, just you just you uh, back to the 2 or 3 lecture. In the graphical method, feasible region are bounded. Feasible region are bounded by several surfaces, and each vertex of this volume, which is a feasible solution, or each point give a one feasible solution for the maximum function, and this is connected to their adjacent vertices by a straight line, by a straight line to each being the intersection of two surfaces. But in a special case of simplex method or simplex algorithm helps to move to another adjacent vertex, which is closest to the optimal solution. Among all adjacent vertices, it follows the shortest route. Means with the help of these four type of special cases, which find the shortest route consist of sequences of basic feasible solution, which is generated by the simplex, simplex algorithm, generated by the simplex algorithm. And this simplex algorithm or simplex method gives the four steps. So four steps. First step for this problem is here. Determine a strategic, basic, feasible solution. First, you determine the strategic, basic, feasible solution, and then move to the step number 2. Right? For this, determine the entering basic variables. Determine the entering basic variables by selecting the non-basic variables without the most negative value in case of maximization. Right? If any problem related to maximization case, then you take here value is most negative value. Or other case, suppose a case of minimization problem, then you will take a most positive value in the jet row. But this is stop if there is no entering variables. The last solution is optimum. Otherwise, go to step number 3. If you get a optimal solution, then stop here, and otherwise go to step number 3. For the step number 3, select a leaving variable. For step number 3, select a leaving variable. Using the feasibility condition. Different type of different cases, different feasibility condition are exist in this problem, and then move to the step number 4. And this step number 4 gives the new basic solution, or you can determine the new basic solution by using the appropriate Gauss-Jordan computation. These are the different types of computation methods. Here, one method is used here, Gauss-Jordan computation method. And repeat step number 2. Means first tabulation is created and then second tabulation is created for this solution. Right? And then move to the simplex table. This is the simplex table. A format of the table a format of the simplex table for some given linear programming problem. Here, xj are decision variables. Here, xj are the decision variables and sj are slack variables. Means here two types of variables are present. First one is x. First one is x, and second variable is sj. Second variable is sj are slack variables, and aij is the coefficient of xj corresponding to ith constraint. Corresponding to the ith constraint. For the non-basic variables, these are the x1 and x2, and the slack variables, these are the s1, s2, and s3. These are three slack variables. And for the solution, here we take a one objective function value. Here the one objective function value, right here one objective function value, and the minimum ratio decide the leaving variable. Decide the leaving variable. These are just like as a b11, a1, a1j, b21, a2j, and b31, a3j. But here these are the b11, b21, and b31. These are the b11, b21, and b31. So take here minimum ratio of this function is here minimum ratio, right? So this is the z row. This is the z row. This is the s1 row. Here is s2 row, and here is s3 row. And basic variables are z is here s1, s2, s3. And for the z function variables are c1, c2, c3, c4, and c5. This b21 shows the right hand side value of the constraints. So the right hand side value of the constraints is here, right? And the special case, for the special case of the simplex method, these are four methods. First is degeneracy, alternative optima, unbound solution, and infeasible solution. These four methods give the different types of problems. And these problems related to the simplex tabulation, right? With these all four cases gives the different types of or we adopt a some steps, and these steps are I will explain one by one. If one tabulation is failed, then go to the second tabulation, and this tabulation gives the entering variable is identified. Here the entering variable is identified. The corresponding column is marked as a pivot column. The corresponding column marked as a pivot column as shown as shown in the next problem, next example problem, and the existing variable from the and the existing variable from the basics is identified or the corresponding row is marked as a pivot row, right? And the next point is here coefficient at intersection of pivot row and pivot column is marked as a pivotal element as shown above. For this basis, the existing variable is replaced by the entering variable and the all element in the pivotal row. All element in the pivotal row and elementary operation is identified such as the coefficient in pivotal column. In the in that row becomes 0 and the same operation is applied for the all other elements, all other elements in that row, and the coefficient are changed accordingly. Coefficient are changed accordingly. A similar procedure is followed in this step, and this is a degeneracy of problem. For the degeneracy problem, a solution of the problem is said to be degenerate solution. A solution of the problem is said to be degenerate solution if the value of at least one basic variable becomes 0. If the value of at least one basic variable becomes 0 and in the simplex table a tie for the minimum ratio occurs which is broken arbitrarily, right? Or or we are used here, it can cause the solution to cycle indefinitely, right? But in the case of graphical method, method is used only two types of variable. Use only two types of variable, and these. But in the simplex or a special case of simplex problem, here more than two variables, more than two variables are used here. In the graphically, it occurs due to the redundant constraints. That is, the constraint that can be removed from the system without changing the feasible solution, right? Without changing the feasible solution, and for the example of this degeneracy problem is here. Consider the problem. The z function is here 3x1 plus 9x2, 3x1 plus 9x2, and is subjected to the constraints of x1 plus 4x2 less than equal 8 and the constraints of x1 plus 2x2 less than equal here is Okay, sorry for disturbance. And here this is a degeneracy of example. This shows the z equal to maximum z function 3x1 plus 9x2, and it is subjected to x1 plus 4x2 less than equal 8, and x1 plus 2x2 less than equal 4, and here x1 x2 greater than equal 0. For this case, just you maintain this tabulation. Basic variables here z0, here is the non-basic variable is here x1 x2, and these variables are, and the feasible variables are like variables s1 x2, and then z0 here right is -3 -9 for this case, and then slack variable is here 0 comma 0 0 0, and for the two slack variables s1 and s2 are here. Then we can write here these constants. 1, this is 4, this is for the slack 1, and here is set for the slack variable 2. Here is 1 2, this 0, and this here is 1, and here is 4. Okay, sorry for the disturbance. Tying what is the minimum ratio for this case? Here the 1 by 8 is 8. This is the maximum, and here 1 by 2, 4 is 4. This is the maximum. So the minimum ratio is here 4 8 by 4 equal to 2, and 4 by 2 equal to 2. This is the minimum ratio for this case, right? And then Z2 -3 by 4, 0, 9 by 4, and 0 and 18 is here, right? This is for the Z2 case. Then entering into the x1 enters and x2 leaves, right? x1 enters and x2 leaves here. For this case, 1 by 4, 1 by 2, right? Here 1 by 4 and 1 by 2 is here. Then 1 by 0, 1 by 4 minus 1 by 2, 0 1, 2 0, set 0. And the Z is here 0 0, 3 by 2, 3 by 2, 18. And x2 is here 0 1, 1 by 2 minus 1 by 2, 2 is here. For the next one, x1 is here 1 0 minus 1 2 comma 0, and the optimal solution for this case is here x1 equal to 0, x2 equal to 2, and the maximum value for this function is here z equal to 18, z equal to 18, right? So x2 becomes 0 in the next term. In the next iteration, x2 becomes 0 in next iteration because of the degeneracy. So this is a one type of degeneracy type of problem, right? Then move to the second type of problem. This is a alternative optima problem. For the alternative optima problem, if the z values for one or more non-basic variables is 0, if the z row value of more than one non-basic variables is 0 in the optimal tabulation, alternate optimal solution are exist for graphically it happens when the objective functions. It happens when the objective function is parallel to a non-redundant binding constraint. These constraints refer to as a that is a satisfied as a equation at the satisfied at the equation as an equation at the optimal solution at the optimal solution is here, right? And the coefficient zero coefficient of non-basic variable x1 indicates that it can be made basic alternative the value of basic variables without changing the value of z without changing of z, and this is the case of optimal alternative optimal condition. This is the case of under optimal condition. And for this example, here maximum z function equal to 2x1 plus 4x2. Maximum z function is here 2x1 plus 4x2. Right. And it is subjected to constraints just like as a x1 plus 2x2 less than equal 5 and x1 plus x2 less than equal 4. Here is x1 and x2 greater than equal 0. For the basic variables x1, x2 and s1, s2, then put the values of the all variables here. First, this is a maximum function. So here we are taking a minus sign here. So minus 2 and minus 4 is here. And these are the 0, 0 variables. For the select variable 1 here, x2 enters and s1 leaves. Then 1, 2, 1 and 1, 1, 1. So this is the basic steps you can follow. The all questions. Then the solution for this here is 5 and 4. Then the minimum ratio. Here in this row gives the 5 by 2, this gives the minimum ratio. And in this row 4 1 gives the minimum ratio, right? And then z2 is here. This is 0, this is 0, this is 2, 0 and 10. For this 10 gives the optimal solution, but coefficient of non-basic variables x1 is 0, indicates that it can be made basic, indicates that it can be made basic is here, and x1 enters and x2 leaves. For this function is here, x1 enters and x2 leaves. For this function is here. Then 1 by 2, here 1 means all function divided by 2 is here. So this is the 1 by 2, here is 1, here is 1 by 2, this is 0, 0, this is 5 by 2. And then similar in this case 1 by 2, 0, minus 1 by 2, here is minus 1 by 2 and 1 and 3 by 2, this is 3, right? Then z3 is here 0, 0, 2 comma 0, this is 10, and this 10, and for this case x2 and x1 is here 0, 1, 1 minus 1, 1, and x1 is here 1, 0, minus 1, 2 comma 3, and this so the alternate optimal solution x1 and x1 are the x1 and x2 are the basic variables. This is the alternative optimal solution case, right? Alternative optimal solution case, and then move to the next special case of the simplex method. This is the unbounded solution. For this case, if any no positive minimum ratio are present, if there is no positive minimum ratio, or all entries of a good column are negative or 0. For example, consider the problem. This is a maximum z function. This z function gives the a value of here z equal to 2x1 plus x2, and this function subjected to a constraints of minus x1 plus x2 less than equal 10, and the minus 2x1 less than equal 40, and then these all values, non-basic variables, are greater than equal to 0, means x1 and x2 greater equal 0 is here. Then the basic variables are here z0, minus 2, minus 1, 0, 0 and 0, and the s1 and s2 are minus 1, 1. Minus 1 comes from this side, 1 from this here, and this is the SAV, this is the suppose here I am taking 1 is here, right? This is the simplex method where select variable problem value is here, right? This is a consider, or we can say that this is a considering value, right? And here is minus 2, and x2 term is here 0. X2 term for this equation is here 0. For this, here we can write 0. Then s1 just like put 0, and here is 1. And the right side of this constraint 10 and 40. So the minimum ratio for this case, minimum ratio, this is the minus 10 is the minimum ratio, and here is minus 10 is also minimum ratio. So this is not a minimum ratio. So here x1 is entering variable, but all the constraints, x1 is the entering variable, but all the constraints coefficient under x1 or under x1 are less than equal to 0, meaning that x1 can be increased indefinitely, which gives unbound solution, right? So this is the case of unbounded solution. And then move to the next and last case. This is the infeasible solution. Here in this case, if at least one artificial variable say positive, if any one artificial variable says positive in the optimum expression, the linear programming problem has two feasible solutions. This situation obviously does not occur when all the constraints are type of less than equal to with non-negative right hand side, because all select variables provide an obvious feasible solution. So this situation occurs a big M method. Means this type of situation occurs in the big M methods. And two-phase method, in which artificial variables are used here. The artificial variables are used here for the better understanding of the infeasible solution. We consider here one example. This is a example. This gives the infeasible solution problem. For example, consider the problem just like a maximum z equal to 3x1 plus 2x2. This is subjected to constraints of 2x1 plus x2 less than equal to, and 3x1 plus 4x2. This is greater than or equal to 12. Here is constraints value are this sign is changed. So this sign it will affect on this slack variables. Will affect on the slack variables, right? And the x1 and x2 are these are the non-basic variables. This is always greater than 0 is here. Always greater than 0 is here. Then z0 z0 minus 3 minus 2 0 comma 0 and 100, right? And this solution is 0 is here. Then select variables for s1 2, this is 2, this is 1, this is 1 for the select variable, here is 0 and then 2 is here. And similarly for the next case r1 is here 3, this is 4 and here is select variable 0, and this minus sign, this select variable minus sign comes from this reverse sign, right? Here is this sign is not less than, this is a greater than sign. So here is negative. And then the previous case, if I am considering previous case, here is less than equal to, then the here select variable is 1. Here is less than equal to, then select variable is here 1. But in this case, here this mathematical signs are changed, then select variable value is equal to minus 1. And then R1 is here 1 also, right? And this is a 12. Then the minimum ratio we cannot find here. Then right, then z0 equal to minus 302 minus 401 100 0 0 minus 1200, and the x2 enters and s1 leaves. Then it will become say 2 1 1 0 0 2 and 2, and this is a 3 4, r1 is here 3 4 0 minus 1 1 12. Only changes in this row, right? And the z1 value is here 501 0 402 100 0 minus 396, and the x2 is here 2 minus 1 minus 1 0 0 2, and the r1 minus 5 0 minus 4 minus 1 1 4, and this minus 396 give the pseudo optimal solution, but artificial variable has a positive value, but artificial variable has a positive value for. So these are the 4 cases related to the special case in simplex method, and these four special cases are degeneracy, alternative optima, unbounded solution, and infeasible solution. I will discuss these 4 types of cases at one by one, right? Then come to the these basic parameter changes the effect the optimal solution. These are the changes in right hand side constant, changes in the cost coefficient, addition for a new variables, and addition for a new constraints. So just you see in this previous last simplex method, whereas only mathematical sign is different, then it will affect the slack variable value. It will affect the slack variable value, right? Then comes to the next problem related to the MCQ problem, right? These are the MCQ problems for this topic here. First stage, operation research, operation research OR, which is a very powerful tool for the decision making process. For the decision making process, this is the correct answer, right? Or operations research, this is a very good tool, or this is a very good uh, way to give decisions, right? And in the second problem, MCQ problem, 2 point in the terms of operation research. GF MC Klosky, FN F15, PF Adams, both A and B. The correct answer for this question is here B. B is the correct answer, right? FN F10. This is the correct answer. Then move to the next question. Question number 3 is here. The term operation research were coined in the year of, this is the year of 1940. This is the correct answer for this question, right? This innovative science of operation research was discovered during Civil War, World War, World War Second, and Industrial Revolution. This science of operation research, this was started from World War Second. So this is the correct answer. World War Second, right? Then move to the next question, question number 5. For this question, operation research was known as an ability to win a war without really going into a without really going into a battlefield, fighting, war, or both A and B. Means operation research, this is a very good tool for the industrial purpose, and without going in the battlefield and fighting, you will win the war. So the correct answer is here is both and B. Both are correct, right? These are the correct answer. Then move to the next question segment. Question number 6. Who defined operation research as scientific method? Who defined operation research as scientific method of providing executive department with a quantitative basis for decisions regarding the operation under their control? These are like a Morse R. Kimball, PMS Blackett, EL Enro, and MJ Netjob, and none of the above. What is the right answer for this question is here? Morse and Kimball. This is the right answer. Right? In 1946. Then move to the question number 7. who defined operation research as scientific approach to a problem solving for executive management. E.L. Ernow, PMS Blackhead, H.M. Wagner, and none of the above. Just think about this question. This is a very important question for this point of view of operation research. So C is the right answer. H.M. Wagner, right? H.M. Wagner defined the operation research as scientific approach to problem solving for a executive management. Problem solving for a executive management, right? And then move to the next step. This is the MCQ problem. Who defined operation research as an ad? Who defined operation research as an ad for the executive in marketing? His decisions by providing him with the quantitative information based on the scientific method of analysis. CKT, H.M. Wagner, E.L. Enroth, and none of the above. The correct answer for this is here CKT. Miss CKT define the operation research as a ad for the executive in marketing. His decision by providing him with the quantitative information, and these information based on the scientific method of analysis. Scientific method of the analysis, right? We'll move to the next question. Question number 9. An operation research has the characteristics. Operation research has the characteristics. It is done by a term of. It is done by a term of scientist, mathematician, academics, and all of the above. This is a terms of scientist, right? Means the operation research has the characteristic that it is done by team of scientists, right? For the 10th question, there is a great scope of for working as a team to solve problem of defense by using a operation research approach. This is the economics, administrator, statistician, and technician. All of the above means all of the above are the correct answer for this question, right? Means all persons used use operation research technique, right? Thanks, Baba. Okay, expect from this. Uh, so here is I am completing the unit number first, and some portion is missing here. This is a simplex algorithm. This is the simplex algorithm, and this gives the basic idea. Start with vertex x star, while x star is not optimal. Find vertex x dash adjacent to x star with ct means c of transport x dash greater than ct x star, and then update the x star equal to x dash as that linear program is unbounded. So this is the last topic for this unit. Unit name is unit number first. And the topic lesson is here linear programming problem, right? And in the upcoming lecture, I will start transportation problem. I will start the transportation problem. This is comes under the unit number 2. Or in the transportation problem, uh, I will discuss about the different types of transportation methods and transportation problems related to the goods transport, warehouse shipping, and rail transport also, air transport, or we can say that the ship transport also. So these type of problems means transportation in India. Transportation medium are four types. First one is road transport, rail transport, or we can say that train transport. Second is air transport, and fourth transport is ship transport. So transporting medium from goods or any other types of uh, devices, these are four types. And the all four kinds of transporting problem related, or we can say that I will cover in this unit number second, right? So the unit number second, this is very important unit for you. So for the today, thank you, all of you. Thanks for this lecture, and I will meet again in the next lecture in this series. Thank you all.